Ground fault circuit interrupters, or GFCIs, are sensitive to ground faults, which can create electrical noise. The radio may be picking up this noise through the power line. Nomex is a fire-resistant material that can create electromagnetic interference, also known as EMI, when it is near electrical wires. This EMI can also be picked up by the radio. A 220 volts conduit for a dryer can also create EMI that can interfere with the radio. Firstly, trip and reset the GFCI to see if the noise goes away. Secondly, use a different radio or electronic device to see if it experiences the same noise. Thirdly, if possible, try to separate the Nomex wiring from the conduit to minimize potential EMI. Fourthly, install a line filter between the radio and the outlet. This can help reduce electrical noise. Fifthly, inspect the circuit panel to ensure that the circuit power in the outlet is not overloaded. It is possible that the GFCI or Nomex wiring is causing the audio noise in the radio. By following the troubleshooting steps, you can try to identify the source of the problem and find a solution. If the issue persists, it is advisable to seek professional assistance from an electrician. Electrical noise can be a frustrating issue, and there are several potential sources to consider. Let's delve deeper into each possible cause and explore further troubleshooting techniques. GFCI sensitivity can indeed be a source of electrical noise. GFCIs are designed to detect even small imbalances in current, which can occur due to ground faults or other electrical anomalies. This sensitivity, while crucial for safety, can also make them susceptible to generating or amplifying noise that affects nearby electronic devices. To further investigate the GFCI as a potential source, try temporarily replacing the GFCI outlet with a standard outlet, ensuring that you understand the safety implications of doing so. If the noise disappears when the GFCI is removed, it strongly suggests that the GFCI is contributing to the problem. Consider trying a different brand or model of GFCI, as some are designed with better noise filtering capabilities. Nomex, while being an excellent fire-resistant material, can sometimes contribute to electromagnetic interference, or EMI. When electrical current flows through wires, it creates electromagnetic fields. If the Nomex is in close proximity to these wires, it can potentially act as an antenna, picking up and re-radiating EMI. This EMI can then interfere with nearby electronic devices, such as your radio. To further investigate Nomex as a potential source of interference, try to physically separate the Nomex wiring from the power lines and other electrical components as much as possible. Use non-conductive spaces or clamps to create distance between the Nomex and the wires. Shielding the Nomex with a grounded metal barrier can also help to block EMI. Ensure that the shielding is properly grounded to provide an effective path for the noise to dissipate. The 220 volts conduit for the dryer can also be a significant source of EMI. High voltage appliances like dryers generate substantial electromagnetic fields which can radiate through the conduit and affect nearby electronics. Ensure that the conduit is properly grounded. A poor ground connection can allow EMI to leak out and interfere with nearby devices. Check the ground connection at the circuit panel and at the appliance to ensure that it is secure and making good contact. Consider using shielded conduit to contain the EMI. Shielded conduit has a layer of metal that blocks the electromagnetic radiation from escaping. Running the dryer's wiring through shielded conduit can significantly reduce EMI. Firstly, resetting the GFCI is a simple but often overlooked troubleshooting step. Sometimes a GFCI can become tripped or develop internal issues that cause it to generate noise. Tripping the GFCI and then resetting it can clear any temporary faults and potentially resolve the noise issue. To reset the GFCI, press the test button on the GFCI outlet. This will trip the GFCI, cutting off power to the circuit. Then press the reset button to restore power. Listen to the radio to see if the noise has disappeared. Secondly, testing with a different radio or electronic device can help determine whether the problem is specific to your radio or a more general issue affecting all electronics in the area. If the noise is present on other devices, it indicates a broader electrical noise problem. If the noise is only present on your radio, it suggests that the radio itself may be particularly sensitive to electrical interference. Try using a portable radio or a battery-powered device to eliminate the possibility of noise coming from the power line. Thirdly, separating the Nomex wiring from the conduit is a crucial step in reducing potential EMI. The closer the Nomex is to the conduit, the greater the chance of EMI being induced into the Nomex and then affecting your radio. Use non-conductive materials, such as plastic spacers or clamps, to maintain a distance between the Nomex and the conduit. The greater the distance, the better the reduction in EMI. Reroute the Nomex wiring if possible to avoid running it parallel to the conduit for extended distances. Parallel runs are more likely to induce EMI than perpendicular crossings. Fourthly, a line filter is a device that is designed to block electrical noise from entering an electronic device through the power cord. It works by attenuating high-frequency noise while allowing the desired AC power to pass through. Choose a line filter that is rated for the appropriate voltage and current for your radio. Ensure that the line filter has the correct plug-in receptacle configuration for your outlet and radio. Install the line filter between the outlet and the radio's power cord. Plug the line filter into the outlet, and then plug the radio's power cord into the line filter. Fifthly, checking the circuit panel is an important step in ensuring that the circuit powering the outlet is not overloaded or experiencing other electrical issues. An overloaded circuit can cause voltage fluctuations and increased electrical noise. Look for any signs of loose connections, burnt wires, or corrosion. Tighten any loose connections and replace any damaged components. Ensure that the circuit breaker is properly sized for the circuit. An undersized breaker can trip frequently, while an oversized breaker can allow the circuit to become overloaded without tripping. If you have access to an electrical meter, measure the voltage at the outlet while the radio is on. A significant voltage drop can indicate an overloaded circuit or a problem with the wiring. Other potential sources of electrical noise include dimmer switches, fluorescent lights, and other electronic devices that generate high-frequency signals. Try turning off these devices one by one to see if the noise disappears. If you identify a specific device as the source of the noise, consider replacing it with a model that is designed to generate less EMI. In some cases, the noise may be coming from outside your home, such as from nearby industrial equipment or power lines. If you suspect an external source of noise, contact your local utility company to investigate. It's crucial to emphasize the importance of safety when working with electricity. If you are not comfortable performing any of these troubleshooting steps, or if you encounter any issues that you are unsure how to handle, it is always best to consult a qualified electrician. They have the expertise and tools to diagnose and repair electrical problems safely and effectively. Electrical problems can be complex and potentially dangerous. It's always better to err on the side of caution and seek professional help when needed. An electrician can thoroughly inspect your electrical system, identify the source of the noise, and recommend the best course of action to resolve the issue. They can also ensure that your electrical system is safe and up to code. Understanding the fundamentals of electrical noise is also important. Electrical noise, also known as electromagnetic interference, or EMI, is unwanted electrical signals that can disrupt the proper functioning of electronic devices. It can manifest as static, buzzing, humming, or other audible disturbances in audio equipment, as well as glitches, errors, or malfunctions in digital devices. EMI can be caused by a variety of sources, both internal and external to a device or system. Internal sources include components such as power supplies, microprocessors, and switching circuits. External sources include power lines, radio transmitters, lighting, and other electronic devices. EMI can be transmitted through the air as radiated emissions or through electrical conductors as conducted emissions. Radiated emissions are electromagnetic waves that propagate through space, while conducted emissions are electrical signals that travel along wires or cables. There are several techniques used to mitigate EMI, including shielding, filtering, grounding, and isolation. Shielding involves enclosing a device or system in a conductive barrier to block electromagnetic radiation. Filtering involves using electronic components to block unwanted frequencies from entering or leaving a device. Grounding involves providing a low impedance path for electrical currents to flow to ground, which helps to dissipate EMI. Isolation involves physically separating sensitive circuits from sources of EMI. Understanding the principles of EMI and mitigation techniques is essential for designing and troubleshooting electronic systems that are immune to noise. You can also examine the grounding of the electrical system. Proper grounding is essential for preventing electrical noise. Ensure that all electrical outlets, appliances, and equipment are properly grounded according to the National Electrical Code, or NEC. Check the ground connections at the circuit panel and at each outlet to ensure that they are secure and making good contact. A loose or corroded ground connection can create a path for electrical noise to enter the system. Consider using a ground loop isolator to break up ground loops, which can be a source of electrical noise. A ground loop occurs when there are multiple ground paths between two pieces of equipment, creating a circulating current that can induce noise. Additional shielding can also help. Shielding involves enclosing electrical components in a conductive barrier to block electromagnetic radiation. Use shielded cables for connecting audio and video equipment. Shielded cables have a layer of metal foil or braid that blocks EMI from entering or leaving the cable. Enclose sensitive electronic devices in metal enclosures to provide additional shielding. Ensure that the enclosures are properly grounded to provide an effective path for the noise to dissipate. Power conditioning also helps to reduce noise. Power conditioners are devices that filter and regulate the incoming AC power to provide a clean and stable power source for electronic devices. Use a power conditioner to protect sensitive electronic equipment from voltage surges, spikes, and other electrical disturbances. Choose a power conditioner that is rated for the appropriate voltage and current for your equipment. Wiring practices can either increase or decrease noise. Follow good wiring practices when installing electrical circuits. Use the correct wire gauge for the circuit to prevent voltage drops and overheating. Avoid running electrical wires parallel to audio or video cables. Parallel runs can induce EMI into the audio or video signals. Use twisted pair wiring for electrical circuits to reduce EMI. Twisted pair wiring cancels out electromagnetic fields, reducing the amount of EMI that is radiated. Consider the location of your electronics. The location of electronic devices can affect their susceptibility to electrical noise. Avoid placing sensitive electronic devices near sources of EMI, such as power transformers, motors, and fluorescent lights. Keep electronic devices away from walls that contain electrical wiring. The wiring can radiate EMI that can interfere with the devices. Experiment with different locations for your electronic devices to find a location where the noise is minimized. If the noise only occurs when certain appliances or equipment are running, try isolating those devices from the rest of the electrical system. Use a separate circuit for the noisy appliance or equipment to prevent it from interfering with other devices. Install a line filter on the noisy appliance or equipment to reduce the amount of EMI that it generates. Consider replacing the noisy appliance or equipment with a model that is designed to generate less EMI. Remember, safety should always be first. Working with electricity can be dangerous. If you are not comfortable performing any of these troubleshooting steps, or if you are unsure how to handle any electrical issues, consult a qualified electrician. An electrician can diagnose and repair electrical problems safely and effectively. They can also ensure that your electrical system is up to code and that it is safe for you and your family. By following these troubleshooting steps, you can identify the source of the electrical noise and take steps to reduce or eliminate it. With a little patience and persistence, you can enjoy clean and clear audio and video signals without the distraction of electrical noise.